Hello class, my name is Michael Gonzales, and today we'll be going over the basics of the mole. Now within the sphere of chemistry, the mole is used as a bridge between multiple different units that can help us to solve problems like how many atoms are in 1 mole of sodium, or what is the mass of 1 mole of sodium. Did you catch what I said? I used moles to relate to the mass of sodium and to the quantity of atoms of sodium using moles. This is rather unique to the mole, since I can't say that there's 70.8 kilograms when asking how many Michael Gonzaleses there are, or one person when asking what is the mass of a Michael Gonzales. These are two different questions that require two different units. However, like I showed at the beginning, moles can be used for both how many the question is how many and how much. The key is to pay attention to the wording so you know what you need to do to solve for them. Let's try a few examples to show how to solve each problem. Let's start with how many atoms are in 1 mole of sodium. And lucky for us, we have a ratio with a given constant that allows us to find how many atoms are in 1 mole of any given sample. This is Avogadro's number. Some people actually remember this constant of remembering the word avocado, which is close enough to Avogadro's number. Man, even I'm slipping up. Avogadro's number. Alright. We know that 1 mole of anything is Avogadro's number of that same thing, and the atoms are moles, depending upon what we're looking for. For example, in any time you're going from moles to atoms, moles to molecules, or vice versa, 1 mole of X equals 6.022 times 10 to the 23rd atoms, or molecules, again, depending upon what you're looking for. We're looking for atoms. 1 mole of a sodium atom is 6.022 times 10 to the 23rd atoms. And 6.022 times 10 to the 23rd let's say we have 8.16 grams of CH4 or methane, and we're going to find how many atoms of hydrogen are present. Well, first, let's find the molar mass of methane so that we can make a ratio of moles. So I've given the molar masses of here carbon and hydrogen. Molar mass of carbon is 12.01 grams, and the molar mass of hydrogen, as we discussed in the last slide, is 1.008 grams. We just add this all together and multiply the molar mass of hydrogen by 4, because there are 4 atoms of hydrogen in the methane molecule, as you can see through the molecular formula. So we end up getting 16.04 grams of methane. Now that we have our conversion factor, we can find out how many moles of methane we have. From here we can determine by looking at the molecular formula, for every 1 mole of methane, there are 4 moles of hydrogen, as you can see there. We can then multiply by Avogadro's number to determine how many moles of hydrogen we have. How many atoms of hydrogen we have present, excuse me. So if we put it all in one step, 8.16 grams of methane times the conversion 1 mole of methane per 16.04 grams of methane. Multiply that by our ratio, 4 moles of hydrogen per 1 mole of methane, and then multiply that by Avogadro's number. We then get 1.23 times 10 to the 24th, 10 to the 24th atoms. Should be 24. There we go. And there you have it, the basics of the mole. For more practice, you can then move on to finding empirical formulas, ampersand composition, and all that fun jazz. Happy solving, folks. See you next week.